horseshoe crabs? Okay. How long do you think they've lived on this earth? Any hands?
1,000 years.
100. 100 million.
A good guess. If anyone has any more questions on those questions too, you will either be answered from the presentation or at the end, where we will have a question and answer session. Classification. Horseshoe crabs belong to a huge group of animals called arthropods. They are placed in a class of their own called Merostomata. Horseshoe crabs are distant relatives of the Atlantic blue crab. Horseshoe crabs are also closely related to spiders, scorpions, and ticks. They breathe without lungs, smell without noses, and chew without jaws. Horseshoe crabs, male and female. Their entire body is protected by a hard shell. They look like a rock lying on sand. Full-grown females are about 2 feet long, including the tail, and can be almost twice the size of males. Evolution. Ancient horseshoe crabs relatives crawled the sand and seafloor around 100 million years before the first dinosaurs appeared on Earth. They have not changed much in their appearance in their 450 million years on Earth. They look so similar to their ancestors that people call them living fossils. Around your appearance, top view. And around your appearance, this is the bottom view. These are the eyes. They have 9 sets of eyes. They are able to detect both visible light and ultraviolet light. These are horseshoe crab legs. They use small pincers for feeding critters. And they have other 5 pairs of long claws. They use the first 4 pairs of legs as big claws for moving. The last pairs of legs are extra long to expand leg structure that help in growing. In adult males, the first 2 legs of chickadees have claws called claspers, shaped like boxes.
The horseshoe crab's tail can be used to flip itself right side up if a heavy wave flips the animal onto its back. The telson cannot be used to sting anything, and it's not a weapon at all. But they do use it to help flow through mud for food. Never pick up a horseshoe crab by the telson. A broken telson could cripple the animal and even lead to its death. A horseshoe crab breathes with gills, but their gills are different from those of any other living animal. A leather-like flap covers 5 pairs of gills. 10 gills hold stacks of about 100 sheets of tissue each that look like the pages of a book. To breathe, the horseshoe crab flaps its book gills, forcing water past the pages. Oxygen in the water passes through the gills and into the bloodstream. If stranded out of water, they can breathe for days as long as its gills stay damp. The hardness of the horseshoe crab's tough, spiny shell protects it from most predators, but one of its predators, the loggerhead turtle, has powerful jaws that can tear into the horseshoe crab shell and eat it anyway.
Shorebirds. Millions of shorebirds descend on Delaware Bay each spring. Red nuts, woody turnstones, cinderlings, and several others can feast on horseshoe crab eggs. Eggs by millions spill from nests because so many eggs lay in the same interdale its own. Scattered eggs become a much-needed banquet for the birds. Typical shorebirds eat an egg every 5 seconds, 14 hours a day, and double their weight in a 2-week bay visit. Diet. Horseshoe crabs are not picky. They will eat almost anything from algae to dead fish. Their favorite foods are marine worms, small clams, and mollusks. They feed on crustaceans and even small fish. They chew without jaws or teeth by moving their legs against short, heavy spines to crush food into bite-sized bits. Habitat. Live in and around shallow ocean waters on soft, sandy, or muddy bottoms. They spend their lives burrowing through the mud and crawling along the bottoms of oceans and saltwater bays. They only come along shore to mate and lay eggs. There are 4 types of horseshoe crabs in this world. 3 species live on the shores of coastal Japan, China, Indonesia, Philippines, and India. The 4th kind, Limnius polyphemus, lives in many places along the western shores of the Atlantic Ocean.
Life cycle. They nest in the intertidal zone in wet sand. The female digs with her legs and shells, scooping out a shallow bowl near the water's edge. She drops about 4,000 eggs in golf ball-sized clusters. She may go on to dig several nests that night, and also crawl ashore 3 to 4 times in the spring, laying a total of 100,000 eggs in a nesting season. Life cycle. Eggs. The eggs are smaller than peas, and many newly laid eggs go from their nests, which leaves only the eggs remaining in the buried deep down to develop. They are soft and gooey when laid, but soon they'll harden. The sunshine and seawater keep the eggs warm and moist for 2 to 4 weeks. Larvae. Eggshells soon split apart and larvae fill the nest. When the next high tide covers the beach, thousands of larvae wash into the bay. After about a week, they settle into the bay bottom. Buried in soft, warm, rich mud, they can safely eat and grow. Molting. They molt several times a year during their first 3 years. After that age, they seem to molt only about once a year until adulthood. It takes about 7 to 10 years to become an adult. They live only about 17 to 18 years. And if you haven't seen, we have a couple of molts right here.
In the early 1900s, horseshoe crabs were conducting tests. People were angry because they eat valuable shellfish. They were encouraged to kill horseshoe crabs and they were rewarded for dead horseshoe crabs. From the 1860s to mid-1900s, horseshoe crabs were used as fertilizers. Around 4 million horseshoe crabs were killed each year around Delaware Bay in the late 1800s. Fishermen have been using horseshoe crabs as bait for eel, whelk, and conch traps. In the recent years, they have reached near 10 stages. We humans threaten the survival of horseshoe crabs by affecting spawning sites and activities. For instance, beach development and shoreline modifications prevent them from reaching sandy sites. Horseshoe crabs play an important role in the ecology and survival of migratory shorebirds. Blue blood. Human blood appears red because it contains iron, and iron moves around the air. And horseshoe crabs have copper in their blood, which makes the blood turn royal blue for oxygen. Horseshoe crabs, amazing lifesavers. Doctors value horseshoe crabs mostly for their blood. In the 1960s, scientists invented a test using horseshoe crab blood to detect endotoxins as bacteria in human medicines. Just a tiny amount of endotoxins that cause in the bloodstream and cause dangerous fevers and even death. Their blood has special blood cells which immediately form a clot in the blood when it does not have the bacteria or endotoxins.
About 200,000 horseshoe crabs are collected each year and shipped to laboratories. Technicians carefully insert a needle into each animal and let the blood drip into a bottle in a few minutes. About 30% of their blood is drawn. Value of the blue blood is $15,000 per quart. Then the horseshoe crabs are returned alive to the water. Any questions or?
Yeah, kids, do you have any questions? Don't have any questions about horseshoe crabs?
We can ask the FLL thing also, they can.
Right, yeah.
Maybe the Lego will be interesting.
Yeah.
You want to see the Lego. FLL thing, you can start. For people who came late.
Okay, this is our Lego Robotics presentation. Lego Robotics is a special set from Lego that lets you build your own robot and program it to do whatever you want. Maybe get something for a fridge or shoot your little brother with a ball launcher.
Okay, components of a Lego Mindstorms 83. So the top corner is the EV3 brick, then the motors and sensors. EV3 brick. It guides the robot according to the computer. It has 4 motors and ports, 4 motor ports, and 4 sensor ports. The ports allow for better movement and sensing. Many people call this the brain of the robot.
Ultrasonic sensor. It can detect the distances of distance of objects and can sense other ultrasonic sensors in the area. Although it's a bad idea to use 2 ultrasonic sensors in one area, which will cause interruption. The light flash pulsar. It was 2 separate sensors before the EV3 came out. Now they are combined. They can check light levels as well as see what color an object is.
The touch sensor. It basically has a button that senses whether it is pressed or not. O for not pressed, 1 for pressed. Gyro sensor. The gyro sensor senses tilt and where it is facing. It's good for robots in uneven places. Lego made a robot that stands on 2 wheels and can compensate for tilt. Infrared sensor functions almost identically to the ultrasonic sensor. It can sense proximity and let your robot be controlled by a remote. Robots can also follow the beacon with the right program. Medium motor. It makes it easier to create arms and other things where much strength is not needed. Very fast and ideal for launching. That's the medium motor.
The large motor. It's ideal for navigation and high power application. It has slight angles to make and easier to build around the motor. What is FLL? Program that lets people learn and compete with Lego robots. Stands for First Lego League. Has 4 segments: local, state, national, international.
It is easy to make an FLL team. All you have to do is get your members and register. There will be expenses, so whoever is in your team has to be ready to pay a certain amount. What to do after your team is formed? Get the mission model, maps, and Lego Education Mindstorm set. Build your robot and tools and start programming the robot to finish missions. Start practice runs and refine your programming to make it even more efficient. Register for a tournament near you that suits you best. Attend the tournament and celebrate!
Does anyone have any questions?
Good presentation.